Okay, so I think we are live now. Good evening, everybody. I hope you are keeping safe and doing well. Welcome back to this second day of our two-day workshop on object-oriented design and design patterns. And I really hope you learned a lot of things yesterday. Today we will be focusing on design patterns, and today is going to be interesting. Trust me, guys. Mr. Shashi Bhushan will be discussing about design patterns, and on top of that, he will also be sharing some of the problems with you. He will be discussing about two real world problems with you. So it is quite interesting. Yesterday was a bit theoretical, and if you really enjoyed that, then you guys are going to love today's session. So I have a few things, a few surprises ready for you, but I will share it with you at the end of this session. So make sure you are here until the end of the session, and you don't just miss anything. Also, we will be announcing about the certificate at the end of the session. Okay, so all the best, guys. Enjoy the session and tell us your how did you like the session in the comment section. Okay, Mr. Shashi will take over from here.
Yeah. Hi,
Hi,
Yash.
sir. How are you?
I'm fine. How are you?
Okay, so yesterday's session was really amazing, and people literally loved it. I saw their love on Instagram. They were showering the comments on the giveaway post, and they're excited about the giveaway as well. So we will be announcing the results of the giveaway at the end of this session only. Okay.
Okay.
So bye, guys. Mr. Shashi will take over from here. Okay.
Okay. Yeah. Hi, everyone. Today I'll talk about few design patterns. Like I'll talk about. Uh, Yesterday I talked about factory and facade. Today I'll talk about composite pattern and flyweight pattern. Right. So these are very important patterns that you should know. And apart from that, I'll discuss some questions, some LLD questions, which are very common to the interviews, right? So that's the idea of today's session, right? Uh, and you can let me know if you're not able to understand something, then you can let me know. I can explain that thing again, right? And I will be using Java to code those things. Uh, but the good thing is that the syntax of Java is quite similar to the syntax of C++ or C Sharp or JavaScript even. So I think you will be able to understand my code easily if you code in C++ or C Sharp or in JavaScript or in Python, because the syntax of Java is quite simple, right? So that's the idea. Uh, Amit, okay, so I'll be sharing the link of yesterday's session in the description, right? So don't worry about that thing. Okay, okay. Let me share my screen and then we can start. Uh, okay, I hope you can see my screen, right? So the agenda is like facade has been discussed yesterday itself. So today I'll start with I'll discuss composite pattern instead of facade, and I'll then start with flyweight, and then I'll talk about some LLD questions, right? Okay. Just wait for a second. Okay. And for that, I'll also talk about like what is the expectation in the interviews and how you can easily crack those, LLA interviews, right? So, and then I'll talk about the two very common interview questions. One is designing parking lot. Second is designing movie ticket booking system. And then I'll talk about the resources from where you can learn all these things, learn the design patterns and everything. Okay. And then we'll have a small Q&A session, like you can ask your doubts if you have any. Okay. Let me quickly. So yesterday I talked about all these things, solid, then SRB, dependency injection, factory and facade. Today I'll start Flyweight. Okay. Uh, yes, certificate will be given in the end, so you'll have to be here at the end, right? Till the end. Okay. Uh, okay. Now let me talk like what is facade and how it is useful for making our design better, for making our design maintainable. Right. So that's the idea. I'll start with Flyweight, and then we can discuss the uh, composite pattern. The idea of Flyweight is, let's say, if I want to, you know, save some space, save some memory, right, by writing some efficient code. So this pattern will help us to, save some memory, right, save some space for us. And how we can do that? Let me show you one example. Like, let's say if you are designing a game, and in that game you might have, let's say, 1,000 bullets. Okay. And let's say we have so bullet is a class, right, which can have fields like size, then weight, and let's say the good thing is that, let's say all these bullets are of same type, so we don't have any field like type or something. uh, Size and weight is, good enough. And let's say the good thing again, one field can be color, right? And let's say all these 1,000 bullets have the same color, right? Okay. So the scenario is, we want to design a game in which we might have thousands of bullets, and all the bullets will have same fields. The size, the weight, and the color of all the bullets will be same. Okay. So the one way could be, like, we can simply create, like, let's say we have one bullet object B1, right? So let's say, to create all these 1,000 objects, what we can do is we can write something like this: bullet B1 is equal to new bullet, right? And then similarly we can write bullet B2 equal to new bullet, and so on, right? So we can have, you know, we can initialize thousands of objects uh, of with the same value. Let's say we have a constructor, and in the constructor we'll be passing some values of weight and size and color, and we'll initialize that bullet object. So here what we are doing is, we are not, I mean, we are creating 1,000 objects which have the same fields, but in the memory, in the RAM, we are allocating space for 1,000 objects, right? uh, so can we do something so that we can save some space, save some memory? Anything that we can do? You can let me know in the comments, like, what can be done. So the idea was, if I want to create 1,000 objects, 1,000 bullets in a game, and all of them have uh, the same type, right? Then can we do something with the help of which we can save some space, some memory in the RAM? Singleton class, no, Gaurav. Here we need to create 1,000 objects, right? So it's not singleton. We can make it static. So this is okay. So see, the B1, B2, B3 is an object, right? So we are creating these objects. Okay, if you will, yeah, static could be one solution. Using a static, what you can do is, you can, I mean, save some space for, so these fields will be shared among all the objects, but still in the RAM you will be creating, uh, you'll be allocating space for all these objects, right? Which is not a good design. Okay. Someone said loop. Okay. loop can be used to, write the code, but in loop also, it's not saving space, right? It's not about the number of code lines. It's about how much space we are allocating in the RAM. Harish and Deepak, see, even if we are storing in array list or any list or any collection, we will have to make these objects, right? We'll have to initialize these objects. So that won't help us to save some space. Okay, it's not about the collection. Someone is saying array, dynamic array, array list. Those things will not help. Okay, so see here, point is, can we save some space instead of creating 1,000 objects? What I'll do is I'll create only one object in the RAM. Let's say this is the memory, this is the RAM, and in the RAM I'll have I'll be allocating only one. Uh, I'll be allocating a space for only one object. Let's say B1 is pointing to this one, right? Now, when I'll be creating another object B2, so instead of creating a new object, what I'll do is I'll write something like this: B2 is equal to B1. Okay. So bullet B2 is equal to B1. Similarly, bullet B3 is equal to B1, right? So here what we are doing is, of course, we'll have this 1,000 bullet variables. Of course, you can store them in an array or in an array list. You can store them anywhere. But the idea is we will have variables, 1,000 variables for bullets. In a way, we'll have 1,000 bullet objects, right? But all of them will be pointing to the same memory location. Like the B2 will point to the same memory location, the B3 will point to the same memory location, right? B4 will point to the same memory location. Okay. So here in RAM we are allocating the space for only a single object, right? Instead of allocating the space for 1,000 objects, right? So that is this idea of saving some space in the RAM is called flyweight pattern. So this pattern, this kind of architecture where we save some space by doing something like this, is known as flyweight pattern. I'll show you one more example, but I hope you got the basic idea, like how in this example we are saving some space in the RAM by allocating only one space. Space for a single object in the RAM, right? So I hope you got this point. Yes, Amaditwar said that, okay. Yeah, so all these 1,000 bullets have the same data. So they will have the same size, weight, and color. So I'm assuming that the fields of all these objects are same. Nikhil is saying you're using the concept of string pool in Java. Nikhil, I'm not using that concept. String pool uses this concept of flyweight. So string pool concept in Java is based on this flyweight pattern. So they use this pattern. It's called flyweight. Okay. So anyone who, I hope some of you got this solution, like how it's working and how it is helping us to save some space. Let me know if it's not clear. I'll explain it again. Okay, so I was asking why we'll have 1,000 objects in the same. So let's say if you're designing a game, in that game you will have 1,000 bullet objects, right? You need 1,000 objects. You need 1,000 bullets, right? So in some cases we might need 1,000 objects, right? Let me write some code so that you can understand like how we can design something like this. Let's see another variation of this problem. Let's say I have 1,000 bullets, but let's say 400 bullets are of red color. See, the size and weights of these bullets are same, but let's say color might be different. So let's say 400, I mean, of them are of red color. Then let's say, uh, 600 bullets are of color black. Now, a single bullet object will not solve this problem, right? So what we can do is, we in this case we need two objects, right? Like we can have, let's say, br, and bullet br is equal to new bullet. So this bullet br is for red bullet, and then we can have bb, right, for black bullet, right? So we need at least two object. Okay, so basically all other 399 red bullets will point to this memory location, and other 599 black bullets will point to this same memory location, right? So if we are initializing a black bullet, in that case I'll initialize, let's say, if let's say there's a bullet b4 which should be of red color. In that case b4 will be equal to br. Similarly, let's say if we have a b5 which is of color black, in that case b5 will point to the black bullet, right? So that's the idea. So we can have the variation, like we can have multiple types of object, but still we are saving a lot of space, right? We are saving a lot of memory in the RAM, because instead of creating 1,000 objects, we are creating only 2 objects in the RAM, and other variables, other references are pointing to the same memory location. Okay. Uh, Now let me show you one more example so that you can understand this Flyweight pattern uh, easily. So let me. So I'll be sharing this. I can simply upload this code on Drive, and I'll share the link in the comment, okay, on YouTube itself. So don't worry about the code. Yeah. So I'm going to create one class called tree. Or let's say I'm going to create a class called bullet only. Let's say bullet class will have fields like uh, size, then the weight, the color. Then we can have constructor of bullet, and then we can have. I'm using Java for coding, but again, the code in C++ will be quite similar to this code. So I don't think language should be an issue for you. So again, these design patterns are independent of the language. Like you can use the same pattern in C++, in Java, in JavaScript, in Python, in any object-oriented language, right? Okay. So don't worry about the language. Yeah. So here we have that bullet class. Uh, okay. The second, actually, I just wanted to discuss one more point. So here, let's say, I mean, see, all these bullets objects are pointed to the same object. So let's say if I'm changing the size or weight or color of this object, in that case, that change will be reflected in all these objects, right? Because they are pointing to the same memory location. Okay. So that's why, I mean, we should not change anything of this object, right? Okay. So that means this should be immutable. Immutable means a class, an object which can't be changed, right? So basically, if we cannot change the value of any field of an object or a class, in that case, that object is called immutable object. Like in Java, we have strings, right? Strings are immutable because they are based on this Flyweight pattern. I mean, if you know the string pool in Java, if you don't know, then you can read about that. I'll talk about that thing as well, like how Java handles the string creation using Flyweight pattern. So I'll talk about that thing as well. But yeah, so the idea of immutable is it's similar to constant. Like we can't change that object. We can't change the value of that object, right? Okay. Because if we'll change that, then that change will be reflected in other objects, right? So the idea is, I mean, we will be using Flyweight pattern only if we have such scenario where we will have a lot of objects of the same type, which will have same values, right? And we are assuming that, okay, uh, those objects will be immutable. That means will not be changing the value of any field of those objects, right? So that's the idea. Yes, yes. Immutable means we can't change it. Yeah. Okay, now let me show you the code. So here we have the bullet object, and I'm assuming that bullet object will be immutable. Like when I'm creating the bullet object, uh, I can initialize the size or weight or color at the time of construction. So we will not have setter methods. Like, I mean, if you don't have setter methods, in that case, we can't change the. And if you don't have a public setter method, in that case, we will not be able to change the value of that field. So I'm removing those setter methods, right? In fact, actually, in the interviews, they can also ask how to design an immutable class. So this is the way you can design an immutable class. Like here, we don't have public setters with the help of which we can set or we can change the value of these fields. So this is one example of immutable class. Okay. Uh, Great. Now let's say we have one class called game where we need to create uh, thousands of bullets, right? Here in the game, we'll have list of bullet, right? List of uh, okay. Let's say in the constructor of the game, what we can do is we can simply initialize all the bullets, right? So we'll be given a size n, and we'll initialize. Let's say the idea is 40% of bullets will be red and 60% of bullet will be black. That's the. So basically here I want to initialize that list of bullets with the help of Flyweight pattern, right? So what I can do is I'll have one class called uh, bullet Flyweight. Class will help us to, you know, create bullet objects easily. So here we'll have a hash map. Explain the logic, like how why we are using a hash map. I'll have a hash map. The key will be the color. So I'm assuming that all other fields of bullet will be same. The only field that can vary is the color, right? So some bullets can have a different color. So yeah, so the key will be string, which will represent color, and the value will be an object of. And then let's say here we'll have a public method called create and the input will be color. Bullet we want to create, right? And sorry, the return type will be bullet, obviously, because we'll be creating a bullet and we'll be returning that bullet object. So the idea is, see, okay, so this method will be called from the game class. Okay, so let me return null for now. Basically, from in the game class will be, okay, so in the game class we'll have that uh, sorry, the bullet flyweight, right? And again, we can inject this dependency using dependency injection. So I can have a I can have a let me initialize this thing in the constructor itself. So I'll be initializing the flyweight. So this is one example of dependency injection. Set, we can have a setter method as well, which can inject that dependency. So this is bullet fly. Now to initialize all these bullet objects, what I'll do is I'll, so let's say, as I said, I want to create 40% black bullets and 40% red bullets, right? Sorry, 60% red bullets, right? So I'll create one variable called count of red bullets, right? Nothing but 0.6 cross n. Okay. This should be a double, but okay. Or what I can do is I can simply do this thing. 6 cross n double. And then let's say I have one more variable called count of black bullets. Should be 40%, right? So what I'll do is in a loop, 0 to let's say I'm going to create red bullet first, right? So I'll be creating that bullet object. Let's say that bullet object is bullet. Get the bullet object, I'll use this flyweight class. I'll call flyweight dot create bullet object. And I'll pass that color called red. Okay. I hope it is visible to everyone. Okay, great. And then I'll add that bullet to this list of bullets, right? Instead of creating the bullet object, what we are doing is we are simply uh, using this flyweight class to create the bullet object, right? So let's see how we can implement this method so that we, instead of creating that 600 objects, will create only one object of red color, and all other objects will point to the same object, right? So let me show you that class. So here what I'll do is, see, if we have already created a bullet for that given color, right? In that case, I'll return the same reference. Okay, so I'll simply check if that hash map this color, that means we have already an object, a bullet of that color. So I don't need to create the new objects. I can simply return the reference of that object, right? So I can return map dot. Basically, to find the value, we have something called get method. This is quite similar in C++ or in Python. In Python, we have dictionary, right? Key will be color. Otherwise, what I'll do is, if that object is not there in the hash map, that means we don't have a bullet of that color. So in that case, we should create a bullet object. Then we will return that bullet object. Okay, let's say the size and let's say the weight will be 5 and 5. And again, in color, I can simply pass that color. So I'm creating a bullet of that given color. Size is integer, float, then color. Uh, that was a float, that's why I have to cast to float. So basically, I'm creating a new bullet object of that given color, and then I'll be inserting that newly created bullet object uh, in the map that we have. The key will be that color, and and the value will be that bullet object. Reference of that bullet object, right? So instead of creating a new bullet object, we are creating the bullet object only if we don't have a bullet object of that given color. Otherwise, we are not creating a new object. We are returning the reference of the object that we have already created, right? Okay. If you can see this thing, right? So now, if let's say if I'm adding, if I want to add a bullet of black color or something, or let's say a bullet of green color, in that case also I don't need to change this code. This code will be same, right? Uh, I'll have to make a change in this class if I want to create some bullets for green color as well. Yeah, so okay, like let's say if the value of n is 1000, right? In that value of count of red bullets will be 600, and the count of black bullets will be 400, right? When this method will be called for the first time for I equal to 0, it will create an object of the red color, right? But for the next time, uh, for I equal to 1, when we'll call this method, this class, this flyweight will return the reference of that object only. Like, will not allocate space in the memory, right? This is how we are saving a lot of space, right? Similarly, if I can write some code for okay, let's say for this is count of black bullet. It looks like here I'll have to pass black as the color. Yeah. So this is how we are. I mean, we are using flyweight pattern, and using that pattern we can save a lot of space, right? So I hope this is clear, like how we are using this thing. Anyone who did not get this idea? Let me know if I should go ahead and. Okay, the short summary is that if we want to create a lot of objects of same type, okay, and let's say if those objects are immutable, in that case we can use this flyweight pattern to save some space in the RAM. So that is the short summary of this pattern. Uh, can we distinguish between objects? I did not get your question. Like, distinguishment what? Like, so see, we have thousand of bullet objects in the list, right? But internally, they are pointing to the same. Like all these 600 black bullets are pointing to the same memory location. Irfan, see, Flyweight is quite different from Singleton, right? Like in Singleton, we create only one object. In Flyweight, we create a lot of objects. They're quite different, right? I don't see any similarity. Why are you creating create bullet object non-static? We can create a static as well. So Jugal, we can create the static as well, right? Static will also open, but normally there's no need of using static here. Okay. I hope some of you have got this pattern. I mean, if you know Java, then in Java there is something called, like in Java, the strings are based on this pattern, right? The strings are immutable and they are based on this pattern. Like when you create, let me show you that example, like how strings are. Let's say if you are so actually in C# also the strings are immutable. Also strings are immutable. When you write something like this, a string s1 is equal to in ABC, right? So what they do is they don't create two different string objects because they have the same value, right? Okay. So what they do is they, okay, let me write one more line. We have something like this, string is equal to ABC. So here the Java will not create three objects for a string. We'll have only a single string object, and these two objects, S2 and S3, will point to the same memory location. So in the RAM, we'll have something like this. This is not true for C++. This is true for Java and C#. At least for Java and C#. Actually, C++ was invented before the invention of this pattern. So that could be one of the reasons that why C++ is still not using this pattern for strings. I mean, that is the only reason I can think of. Okay, so basically, for S1 we have for that string, S1 will have some allocated space in the RAM, right? And the value of S1 is ABC. So now the S2 and S3, both of them will point to the same location, right? And now let's see if I'm changing the value of S1. In that case, that change will be reflected in S2 and S3 both, right? Okay, that's why the strings are immutable in Java. Like you can't change the value of strings in Java. For that thing, we have string builder and string buffer in Java. you can change the string builder and the string buffer in Java, but you can't change the value of strings in Java because they are immutable, because they are based on this pattern. So I hope you got the idea of this thing. Sachin, the real life example is the string, right? The string in Java. And of course, when you design something like a game where you create a lots of objects like bullet, we can use the pattern. Um, yes, MSP Prasad, yes, it's correct. Okay. Now let me start with the new pattern, which is composite pattern. It's also an interesting pattern. So let me start with that new pattern called composite pattern. Composite pattern. So let's understand this pattern with one example. Let's say we are uh, so Rahul, as I have said, uh, we can't update the property of that object, right? So that is the meaning of immutability. So the objects are immutable. We can't change any field of that object. That's why we are using Flyweight here. So we can't update any property. Okay. So the idea was, if all the objects are immutable and if all the objects are of same type, they have, like in bullet, they have same weight, they have same color, they have same size. That's why we are using this pattern. If we need different objects with different properties, like, okay, like let's say in Facebook, right, they have, I mean, let's say they have a class called user, right? And again, all the users will have different properties, like the ID of user will be different, the name could be different, the email ID could be different, right? So we can't use the Flyweight pattern in that case. Like in Facebook, they have more than 1 billion users. Still, we can't use Flyweight pattern to save some space, because all these objects have different properties, right? All these users will have different name, different email ID, different ID, different mobile number. So we can't use that pattern here. The idea of this pattern is, if we are building something like a game where we can have thousands of bullets of same type, of same size, of same color, of same height, then only we should go with this pattern. Vishal, yes, you can create your own string pool thing using Flyweight. Okay, nice. Uh, let's talk about the next pattern, which is composite pattern. So let's think about one scenario. Let's say we are designing a system like e-commerce, and let's say we need to sell uh, we can have a product called pencil. So we can have a single pencil, or sometimes we can have a packet of pencil. We can have a small packet of pencil, right? And in that small packet of pencil, we can have, let's say, 5 pencils. Okay. Similarly, we can have a bigger packet, and in that bigger packet, we can have multiple small packets, right? And let's say we can have a box, and in that box, let's say we can have some packets of pencils. We can have some normal pencils, right? So we can have some normal we can have, let's say, some pencils in that box, and let's say within that box we can have some other items, like we can have let's say we can have some notebook, right? Let's say we can have some notebooks, then we can have some packets of notebook, right? So the idea is, okay, let me explain like this. Mm, Like let's say here we'll have a box or packet, bigger box or bigger packet, and within that box we can have some boxes, or we can have some items. Like we can have, let's say, one pencil and one notebook. So let's say within a single box we have two small boxes and one pencil and one notebook, right? Similarly, within this box we can have only, let's say, we can have three pencils. Within this box we can have, let's say, two smaller boxes, and let's say within this box we can have, let's say, a notebook, and let's say within this box we can have one notebook and one pencil or something. So if we want to, store these objects somewhere, then how we can design that collection, or how we can design. uh, so the idea is I want to create classes for these packets, right? So within a packet, within a box, we can have multiple packets, or we can have multiple items. Okay. So what will be the fields of, like, how we can uh, create, how we can design classes for this kind of thing, where within a packet we can have multiple packets and multiple items. Okay. So I hope you got the requirement. Tree. Someone said tree. Um, So Rahul, yes, the string pool is based on that flyweight pattern only. Like in the string pool, let's say for ABC they will create one string object, and if we have some more strings with the same value, then other strings objects will point to the same location, same memory location. List of objects containing list of. Yeah, Rahul Jan is correct. Tree. It looks like an Henry tree, or you can think like a file system, right? Like, so again, it's a very common interview question. Like they can tell you to design a file system. So within a folder we can have some smaller folders, we can have some files, then within this folder we can have some folders, also we can have some files, right? Within this folder we can also have some files, and so on, right? So basically within a folder we can have some folders and some files, and but yes, within a file we can't have another file, or we can't have another folder, right? So this is quite similar to this packet or box architecture. If I can compare this thing with tree architecture, it's a kind of tree. It's an binary tree. Like in binary tree, binary means two, right? So in case of binary tree, a node can have only two child. Okay. But in case of binary tree, a node can have n child. Okay. Um, okay. So basically, like let's say this node is the packet or box, and within this node we can have other boxes, and we can have some items. So let's say I'm representing items by this thing, by the marked node, right? Within that box we can have two boxes or multiple boxes. Within this box we can have a single box and one item. Here also we can have one item. Let's say within that box we have one item. Within that box we have, let's say, two items, right? And within this box, let's say we have one more item. Okay. So if you can see, this is like a tree. This is the root node, and it has four children. This one, this one, this one, this one. And some of them are leaf nodes, right? So here items are leaf node. Okay, so basically file or items. Leaf node means file or item. The file in the file system or item in this box architecture, right? And then this non-leaf node is nothing but a folder or a box, a packet, right? So this non-leaf node is a box or folder where we can have multiple files in multiple folders. Okay, so we can represent this thing as a tree, and a tree node can have multiple children. Some of the nodes can be leaf nodes like the items, okay? And some nodes can be non-leaf nodes, right? So it is quite similar to tree. So this node is called leaf node and this node is called non-leaf, or it is also called composite node, because it's like a packet. It's a composition of multiple objects. That's why it's called composite object. Okay. Uh, I hope you got the basically like how. So someone's saying voice also, because I want to make sure that everyone can understand this thing. Well, uh, right. So how we can create classes for this thing? Let's say if we have this architecture, then how we can create classes? I mean, if you code, I mean, if you have written code for tree, in normal tree, what we do is, in normal tree node, we'll have some data, we'll have the reference to the left node, we'll have the reference to the right node. But here, a single node can have multiple children, right? That's why we need to keep a list of node, okay, within a node, right? In a normal binary tree, a node will store the reference of its two child, left and right child. But here we have a list of children, so the node will have a list of nodes, right? So let me define the architecture. So we'll have a interface. Yes, just wait for 1 second. Sorry. Yeah. So the architecture could be something like this. We can have a base interface, right? And this base, I mean, this is the node, right? This is nothing but the node, which can be of two types. So we can have a leaf node, which can be considered as, let's say, item. I mean, the leaf node, right? This can be considered the leaf node. Okay. Again, that item can be, it can be a pencil, it can be a notebook or something. So it can be of multiple types. In case of file, this item can be file. Then we can have a non-leaf node. Like node is of two types. One is leaf and one is non-leaf node, right? And if we talk about the fields of this non-leaf node, we'll have a list of what? Anyone? Let's say the name of this interface is node, and let's say the name of this class is item, and let's say the name of this class is box, because it is a non-leaf node, right? So if it's a box, so what would be the fields of box? Like, so in box, of course, we'll have a list of I mean, so in this list I want to store some items, I want to store some small boxes. So what will be the type of this list? Anyone? List of node, right? Yeah, list of node. So the type will be list of node, which is the base interface, right? Which is this interface, this class. See, the idea is if the list is of type of node, then again this node can be an item, it also can be a box. Okay, like let's say if this list has 5 elements, so some elements can be box, some elements can be items, right? So that's why the type of this list is list of node, list of that base class, which is the interface of the base class. Someone said try. Yeah, try is similar to tree, right? Try is nothing but an extension of trees, right? Try is nothing but a entry tree. Okay. Uh, yeah, and if I can, and let's say this one method called get price. So let's say items will have a field called price, and this one method called get price in which I'll return the price of that item. And let's say again, every node will have a method called get price. Okay. So in that method, I'll have to return the price of that item. So if it is a box, the price of a box will be the sum of the total items within that box. Okay. So how we can implement this get price method for this box class? Okay, let me write some code so that you can have some more clarity. So let's say here I have a class called node, or let's say we have a class called, yeah, it can be interface, right? So this node is the base interface, right? So let's say there's a method called get price, which will be there in the interface, right? Then let's say again this interface will be extended, will be implemented by two classes. One is item class, right? Let's say for simplicity we have a single type of item. Let's say we have only pencils, right? So let's talk about only pencils. So that will have some simple code. So the pencil class will implement the base interface called uh, no, right? This class is, we'll have to implement that method. So this class will have a field called price with a private field. So I can simply return that variable, right? Yeah. And in the constructor, I can initialize the price, or we can have a setter method that can. Oh, okay, let me set the price in the constructor. This is the cost. Fine. So this pencil class is like, if you can see, I was talking about this item class. So this is the pencil class. And then we'll have one more class, the box class, the packet class, which will be non-leaf node, which will have a list of node, right? So let me create one more class called box. So this is the leaf node, right? Which is similar to file class in the file system. Let me create one more class, which will be box class, which will be similar to packet, or this is the on leaf, or it can be considered as packet, be considered as folder in the file system. The box again, uh, okay, so here we'll have a list of node, right? This is the base class. Node can be either a box or a pencil, right? So let's say this is items or something, for a simple list. Now, of course, this box will implement the base interface called node. I have to implement that, override that get price method, right? Again, we'll have some methods like a method called add item. It will be a void method, and the input will be a node. Basically, in this method, I'll be adding some items in the list, right? We can call that method to add some items in the list. And in the constructor of box, we can simply initialize This list as what do you think? What will be the code for this get price method? So the price of a box will be the sum of the price of all the pencils in that box. So how you can implement that method? Saransh, this pattern is helping us to provide a way so that we can uh, design a class for this scenario. Yes, we have to iterate in the tree. So yeah, so how we can iterate in the tree? Yes, the that's right. I mean, if you can see, what we have to do is we have to iterate in the tree. It's not simple loop, Rahul. It's not a simple loop. We'll have to tree in the loop. We'll have to iterate in the tree. We'll have to go to the each leaf node, right, which is the pencil object, and then we'll have to call the get price method of the pencil object to get the price of that pencil, and we'll be adding them. So if I can show you some code, it's not a simple loop. It's a recursive loop. It's a similar to DFS, right? It's a similar to what to say? It's a similar to pre-ordered reversal of a tree, entry tree, which is nothing but a DFS. So we can write something like this: price is equal to 0, and then we can. It's not a simple loop. We'll have to, you know, we'll have to call the function recursively. Items dot size I plus plus, right? And now what I'll do is I'll simply add price equal to price plus. I want to find the price of that item, which is the part of this box. So I'll have to call uh, I'll have to call items dot get. So basically I'm accessing the ith element of that list, and then I'm calling the get price method, and then I'll return the price, right? Within a box, within a simple box, if you have two boxes, right, then what we are doing is we are iterating in that list of boxes, and we are again calling the get price method of that box. Okay, so this item can be a pencil, or this item can be a box, right? So if it's a box, then in that case we'll call the same function again of the inner box. Okay. uh, yes, it's a simple recursion. It's similar to DFS, right? So this is how you can implement this pattern, and the idea of this pattern is it helps us to helps us to find a way to uh, to create classes for such complex objects. Okay. Can we say that this pattern solves problem solving a problem having trees like hierarchy? Yes. So see, the one common question is like this question, like let's say if you're designing an e-commerce, and then how you will create classes for these things, or if you want to design a file system, then how you will be creating classes for the system, right? So we'll have to think something like this. Okay. So we can use this pattern if we have something similar. Yeah, it is similar to cart in e-commerce, right? Yeah. So let me know if you have any doubt in this solution. Or anyone who is not able to understand this thing. Where Java includes this pattern, there are many examples where Java uses this thing. I mean, if you know the tree set, or if you know the file structure of Java, they use this pattern. So you can explore the uh, So the code of JDK is given, and it's a public code, so you can have a look at the code, like how Java has implemented these things. Yeah. There is okay. So what you can do is you can simply go through the video again. I hope you'll be able to understand it, because if I'll repeat it again, it might be uh, time waste for some of you. Gaurav, we'll have to iterate in the list, right? So what is the cost of this function? The cost of this function is, it's a DFS, right? The cost of DFS is total number of nodes in the uh, tree, right? So it's off and only. Okay. Uh, okay. So any other doubt regarding application? As I said, like application is if we want to store something like a tree or something like a file system or something like an e-commerce. In that case, it can be useful. Uh, okay. Any other query that you want to ask? Okay. I think we are done with this pattern. So let's move to the next topic, which is solving some questions on these patterns, right? Like what you can expect in these interviews, right? Okay. Um, So let's talk about the interviews, right? Like again, I don't have much time to discuss all the patterns. So the idea was just to describe some patterns so that you can know, like, okay, how these patterns are helping us to design, to make our design better, right? To make our code maintainable. So that was the idea. Let me talk about the interviews. Okay. Again, I mean, apart from coding rounds, you will have design rounds, right? Which is normally called system design. So system design will have two types, or I would say two parts. Okay. One is called HLD and high level design, and one is called LLD, right? So in HLD we talk about uh, we normally talk about the web application, like how we can scale that web service, how to design the REST APIs, how to design the databases, how to use a cache, how to use a messaging queue like Kafka, how to use CDN. So we talk about all these things so that we can make our application scalable, so that we can make our application uh, available all the time, so that we can make our application consistent. So in high level design, we talk about the components of the higher components of the system, like servers, the APIs, the databases, the cache, the messaging queue, the CDN, the load balancer, the API gateway. So we talk about all those things, right? Uh, let's say someone is working on uh, desktop application, or let's say if someone is working in EDA, or uh, if you're building uh, an application which is standard and which is not on web, in that case, they might not ask questions on HLD, because HLD is only for those who have worked on web, right? Either on front end or back end, normally on back end. So because if you have worked on back end, then only you will be able to, like, okay, what is load balancer, what is the REST APIs, what is the database, and how to design database in a proper way, right? Yeah. So initially we talk about all those things, and if your experience is 3+ years, right, and if you have worked on web, in that case you can expect these questions in the interviews, right? There are many resources that you can learn HLD, right? There's some books, there are some YouTube videos. Again, on Geeks we have a course on design, system design, which is for HLD, right? Then another thing is LLD, right? Low level design. In this design, we talked about the low level components, like how will be the interfaces, how will be the classes, what will be the fields of the classes, how the classes will be interacting with each other, right? So yeah, so in this design we talk about object and classes and their interaction, and uh, basically how you will implement a function so that your code can be maintainable, right? So in this round you will have to create some classes, you might have to write some code as well. Okay, so here we you will have to use the concept of object oriented design and design patterns, right? And using all these things you can design something better. So in this round the expectation is if you know the basics of design and design patterns, you'll be able to solve those questions, you'll be able to apply those patterns to solve that problem, right? uh, and of course this again, normally companies don't ask these questions to freshers, but again, if you're a fresher then also you can expect some questions on singleton, some questions on factory in the interviews. They can ask some basic low-level design questions like designing a snake game, designing a chess game, designing a tic-tac-toe game. So these are very basic LLD questions which can be asked to the freshers, right? So I mean, you should know the. So if you're a fresher, at least you should know the OD thing, and you can know the basics of patterns. Like you can know the factory, you can know the facade, you can know the singleton, you can know about observer, right? But yeah, but let's say if your experience is 1 plus or 2 plus years of experience, right? And let's say if you have experience of in fact 10 years, right? In that case also they might ask some questions on LLD, and irrespective of your domain, like let's say if you are working either on back end or front end, or you are an Android developer, or you are iOS developer, or you are uh, working on let's say desktop application. So it is irrespective of domain, you can be asked these questions, because again these things are used everywhere, right? Because we have some patterns in JavaScript that is used in frameworks like Angular or React.js, right? Or let's say if you're using a backend thing like Spring or Django or Node.js or something, of course these patterns are used there. If you are building a game, or if you are using C++ to build some desktop app, in that case also these things are used. That's why, I mean, irrespective of your domain, they will be, you can expect these questions, right? The questions on LLD. So let's see how you should tackle these questions, and you can let me know your doubt, like if you have any like about LLD, then you can let me know. I can explain more about that. But let's I'll talk about so we don't have a lot of time. So I'll talk about one or two questions, and I'll try to solve this question and help you to like okay how you can apply these patterns and these principles to uh, design a better system, right? So that's the idea. Okay. Again, as I said in the interviews, they expect that you should know the basics of OOD and design patterns. You should know what is facade. You should know what is SRP. You should know what is OCP. Right. You should know what is interface and when to use them. Okay. So that's the idea. Let me discuss one very common interview question, which is designing a parking lot. So the question is designing a parking lot. Right. So the first thing that you should do is you should clarify the requirement. You should clarify the sorry, requirement, right? Like you should gather the requirement so that you know that okay, we are going to build this thing. So the first step is you should ask a lot of questions to the interviewer to know about the system, right? And then uh, I mean once you're done with the requirement gathering, you can start with designing the classes for that system, and then you'll have to uh, create a relationship or the interaction between them, like how these classes will be interacting with each other to uh, complete the feature of that system. Okay, here you'll have to use some patterns, right? Okay, and then in last you might have to implement some functions. You might have to talk about like what will be the fields of that class, what will like how those methods calls will be invoked. So yeah, you'll have to I mean, again, you won't have that much time to write the code for everything, but still you might have to write some you might have to write some code, but normally they might ask you to implement one of the functions, right? So that's the expectation in the LLE rounds. Okay, so let's see like how we can tackle this problem, designing a parking lot. Okay, uh, just wait for a second. Sorry, audio is back. I hope the audio should be back. Hello. I think the audio issue should be resolved. Okay, thanks. The audio is back now. Okay. So what I was saying is, okay, looks like when I'm removing the video, the audio is removed. Okay, that's not the issue. So what I was saying is, when we talk about the requirement, when we talk about the features of the system, I mean, you might have to talk about that. Okay, the system will have, these features like the parking lot will have an entry gate, the parking lot will have an exit gate, the parking lot will have multiple floors, and on each floor we can have multiple parking spots. And some spots will be for cars, some spots will be for bike. So we'll have multiple types of parking spot, right? Uh, okay. So, and let's say if you're assuming something, let's say you're assuming that okay, the parking lot will have only a single floor. In that case, you will have to mention those assumptions to the interview, like okay, I'm assuming all these things, right? Or I'm going to build the system for this feature, or I'm adding all these features in my system, right? So you will have to freeze the requirement first, and then you should start with designing the classes, right? So if we can uh, so yeah, if we can think about the classes for this system, so the one obvious rule is, if you write down all these requirements in plain English, so you can pick the nouns, and the nouns will be your objects, your classes, right? Like here we have one noun like parking lot, we have one noun like floor. Let's say we'll have a display board where we'll be displaying something, so the display board should be one object, one class. We have a parking spot, we have a vehicle. So basically all these things should be a class, all these things should be an object of our system, right? So that is a simple rule to identify the classes. Right. So let's say here we'll have a class for vehicle. The vehicle can be of multiple types. The vehicle can, like the car or bike, or let's say we can have some other type of vehicle. The fields can be the vehicle ID, the number or something, or some other fields like color or something. Right. Then we can have one more field called, let me write the classes in the code itself so that you can understand things easily. Uh, okay, let me write all these things here. So let's say, so what I was saying is we'll have a class called vehicle, which is the base class, right? And it can have fields like vehicle ID or vehicle number, which will be unique. Then we can have some other fields as well. Then a class like car or bike can extend that base class called vehicle, right? Let's say again we'll have one more class called parking floor. Uh, right, because the parking lot system will have multiple parking floors, so we need a class for parking floor. What do you think? What should be the fields of this parking floor? See, we have one more class called parking spot, and the parking floor will have a list of parking spots, right? Parking spot is a place where we'll be parking something, right? So it can have fields like the ID, the unique ID, like A2 or A12 or something, just to, so basically some ID for that parking spot. And again, we can have an enum, which type of uh, what is the type of that spot? Is it for car or is it for bike, right? So we can have, let's say, okay, let's say we have an enum called uh, what type, and some values. So let me ignore those things for now. So it will be, then it can have fields like a boolean field like is it free or not, right? So we can have some other fields. Now the parking floor will have a list of parking spots, right? Spots, right? Uh, uh, yeah, so parking floor will have a list of parking spot. What else? Every parking floor will have a display, so that, so we'll have one more class called display class, which will be displaying something on the board. This display is nothing but the display board, right? Which will have a method to display something. So let's ignore that thing for now. Parking floor will have one object of display, which will be used to display something. Then we'll have the facade class, the main class, which will be parking spot. Parking lot, right? So the parking lot system is the main facade class. If you know about the facade class, I had talked about that thing yesterday, right? So parking lot will be, right, it can be called as parking system, and then it will have a list of parking floors, right? Because this parking lot will have multiple floors. The parking system will have a list of parking floors, right? Apart from that, the parking floor will have we need a class that can handle the ticketing thing, right? So we'll have a class called ticket manager, which will be responsible for managing the tickets, right? So we'll have a class called ticket manager, and let's say we have one more. Again, we'll have a class for ticket. Yeah. So now the the parking lot system will have an instance of ticket manager, which will take care of the. Right. So basically, the idea is when a user will enter the system, then the ticket manager will generate an e-ticket for that person. Okay. Right. Okay. So again, we can have a class called. I can't complete the code within that given time. So what I can do is I I can share the complete code after some time. Let me discuss the important concepts like what we can do here. Yes, the ticket will have fields like ticket ID, which will be unique, uh, the vehicle ID, the ticket can store the parking spot ID, but let's ignore that thing for now. Uh, it can have field like time of entrance, right? Like when we are entering to the system, right? Time of entry, right? We'll have one more field called time of exit, right? Time of exit. We can have some other fields. Again, we can have one more class called payment details, which will be used to store the payment details. Payment details. And fields like the payment ID, the fields like payment mode, right? Online or cash or something. And one field like amount, the status, the card number, everything, right? So it can have a lot of fields. And a ticket will have one field called payment details. So initially, the payment details will be null at the time of the entry, but when a user will exit from the exit gate, in that case, we'll update that ticket details. The payment details of that ticket. This is the payment details. We can have some more fields, right? And this ticket manager will have again list of tickets. So basically, we'll be storing all the tickets just for the future use, right? This thing is also, so if you're storing something, let's say tickets, this thing is based on a pattern called memento pattern. If you know memento, this is based on memento pattern, right? This thing is based on facade pattern, right? Okay. The main system will have a method called entry, right, which will return a ticket. There's a method called entry, and uh, the input can be the vehicle ID or something. Vehicle ID. Other things are not required, right? So what we'll do is, again, this ticket manager will have one method called uh, generate ticket or something. Generate ticket and with the vehicle ID. Here we'll create an object of ticket. and we'll initialize fields like the ticket ID, which can be auto increment. Vehicle ID is this. Ticket ID will be something auto increment, right? Uh, and then we can set the time of entry of the current time. This will be null. This will be null, right? And then I can return this object. Basically, I'll set some of the fields like vehicle ID and this ticket ID and time of entry, and then we'll return that ticket object, right? And at the time of exit, there will be one method called exit. At the time of exit, we'll update the details of ticket with payment details with time of exit, and then we store the ticket again in this list, right? So when we are generating a ticket, I'll be storing that ticket in this list, right? So that we can know about that ticket at the exit gate or something. Right. Yeah. So in the entry time, what we are doing is we are simply calling uh, ticket manager dot generate ticket method. Again, in the interviews, you will not be told to implement all these functions. But the idea is you should know about the classes. Like you will have this class, you will have this class. So you will have so many classes in that system, and you will have to talk about all these things, right? Uh, Again, there will be one method in this class which will be used to calculate the price. So we'll have one method called calculate fees or something, calculate price or calculate charge or something, right? And the input can be the ticket. So based on the entry time, based on the exit time, and based on the type of the vehicle, we can uh, so we can have one more field called vehicle type, right? Or so we can a string called vehicle type. Based on the vehicle type and the duration, uh, we'll have to calculate the price, right? There can be multiple algorithms to implement that, and here we can use one pattern called strategy pattern. Strategy. If you know strategy pattern, you can easily apply here. Strategy pattern. Again, I don't have that much time to discuss all these things, right? So I can't discuss the moment or strategy here. But the idea is, if you know these patterns, you can easily apply these things to design something like this, right? Okay. So at the exit time, we'll be using this method to calculate the price based on vehicle type and duration. Again, we can have some other logic as well. Yeah. Uh, Again, we can use one more pattern called observer pattern. Let's say when a user is filling a spot, parking spot, in that case, we'll have to update the display, right? We might have to update the multiple displays. So that is an application of observer pattern, right? So that's the idea. I can't write the complete code here, so I'll be sharing the link of the complete code so that you can go through them. I just wanted to explain, like, okay, how these patterns are used to solve these questions, right? And how we can use these patterns to build something. And the purpose of asking these questions in the interview is just to check whether you know about these things or not, whether you know what is facade and how to use them, what is observer and when to use them, right? So if you know these things, then you can easily apply these things to answer the questions, right? Okay, we don't have much time left, so let's have like you can ask your doubts regarding LLE interviews, right? You can let me know your questions, and I can answer your questions, right, for 10 minutes, and then in last yeah, And then in last, of course, I'll be sharing the link in the comment of the this video. So this video will be there on the YouTube, so I'll be sharing the link in the comment section, right? So you can ask your questions regarding LLD interviews or anything. And one more thing, actually, if you want to learn all these things by me, then uh, on Geeks for Geeks we have one course. So if you know that Geeks for Geeks, Dan Patton's live course. So in that course, we talk about all these things, like how to, uh, I mean, all these patterns and how to apply these patterns to solve some LLD questions in the interviews, right? So I have shared the link of this course in the comment section. I mean, in the video description, you can explore that course, right? Yeah. Here we'll be talking about all the principles and patterns and some questions which are common for the interviews, right? So that's the idea. Again, if you want to learn these things by yourself, again, there are some books which you can follow. Let me, okay. Yeah, if I talk about the resources for learning all these things, uh, again, I mean, you can join that course. That is the one resource. If you want to learn by yourself, then you can go through some books, like one book is Head First, Object Oriented Design and Analysis, right? And the second book is Head First, Design Patterns. Then third book is Architecture of Enterprise Application. I mean, sorry, Patterns for Enterprise Application. Okay. So again, I'll be sharing the list of the books in the comment section so that you can have that list. There are some other blogs on Geeks for Geeks. Also, there are some articles based on this thing, so you can also go through them to know about the questions, to know about the patterns, right? Yeah, so these are the three books which are really good. But apart from that, you can read the book called Clean Code. There's one more book called Clean Coder, right? So one book is Clean Code, one book is Clean Coder, and one book is Clean Architecture. So all these three books are written by the same author, uh, Uncle Bob. So his name is Uncle Bob. Clean Architecture, right? So you can also read these books, right? So I'll be sharing all these links in the comment section. You can let me know if you have any doubt regarding these things. Okay, the one question from Saransh is, can you recommend some good companies which take interviews mainly on DS and Algo? See, most of the companies ask questions on DS and Algo only. Like all the companies like Microsoft, Amazon, Adobe, all the top companies ask questions on LLD as well. Apart from these top companies, there are some good startups like which are really good, like companies like Swiggy, Zomato, Ola, then Hotstar, Curefit, uh, Paytm. All these companies are really good, right? So you can start your career with these things. I mean, this with these companies. Recommend. Yeah, for basics, go through the you can go through that book, actually, the Head First AD book is really good, right? So you can go through that book. Yes, App Labs is also good. Yes, meet. They can ask questions on these things, so you should know the basics of OOPS, right? Yeah, some startups are asking for the projects. Yes, it's true. Yeah, but most of them ask questions on DSNL only. Okay, so now I think I'm done from my side. So Yash can join me and he can continue with the announcement.
Okay, so that was a really wonderful session, and we literally enjoyed it.
Okay, thank you.
And I hope everybody else enjoyed the session. So, guys, tell us how was it. If it was really good, then we are planning to bring more workshops like this on a frequent basis.
Right. You can also let us know like on which topic do you want to do workshop, like anything on
Yes,
front end
go
or
ahead.
back end.
Tell us in the comments what topic would you like to bring us our next workshop on.
Right.
Okay, great. So there are people who really love the workshop. That's great, Shashwar. You have rocked like always. This is really
Thank you.
impressive. Okay, so and it's time for our announcement of a few things. So the first thing is, guys, um, what would you like to hear first? The winner of this giveaway award, this giveaway of premium, Geeks for Geeks premium, or would you like to know about the certificate first? What do you guys say? Okay, certificates. Okay, guys. So I have we have posted the link in the description for the certificate, and you can go out and fill the form. The form will be accepting responses only for 15 minutes post the workshop time. So the form will be open only till 7:15. Okay, so we won't be accepting any responses post that. So if you really want the certificate, then go head out to the form, go to the link, and just fill out the form and claim your certificate. You will receive the certificate within 10 days from today. Okay. Secondly, the winner for the Geeks for Geeks Premium is Sushma Reddy. Okay, there was a really good comment, and guys, all those who didn't win this giveaway this time need not feel bad about it. We are going to bring more such workshops, and we will definitely plan some giveaways in those workshops as well. Meanwhile, if you wish to try out Geeks for Geeks Premium and Premium Plus, you can go for the 1 week free access. Okay, so there is a 1 week trial where you can get to know how Premium and Premium Plus works, or do you really even like it or not. Okay. Finally, I just had a word with the management, and guys, we have got a flat 10% discount on the ODL course for you. That's Object Oriented Design and Design Patterns live course by Mr. Shashi Bhushan, which he just discussed about, right? So you can get flat 10% off if you use the coupon OODL 3OCT. Everything is mentioned in the description itself. The certificate link is in the description. The link to Geeks for Geeks Premium is in the description. And this coupon is also there in the description. Okay, guys. I hope you really enjoyed the session, and we are planning to bring more workshops like this. Okay, so if you want to share like what topics should the next workshop be on, then shoot us on Instagram DM. I guess that will be a really good option. We guys can have a chat there. Okay, guys. Bye. Take care. Stay safe. Stay home. And please wear mask when you go out. Okay. Bye, guys.